S3 backend example. Terraform state needs a shared storage location. An S3 backend stores state outside the working directory. Remote state lets others read the same infrastructure record. The backend must exist before Terraform can store state there. The S3 bucket becomes a storage container for state. Terraform writes the state object into this bucket. A unique bucket name prevents AWS namespace collisions. The account placeholder keeps the example safe to publish. Versioning keeps older copies of the state object. A bad write no longer destroys the only record. Rollback becomes possible through S3 object versions. State recovery depends on history existing before failure. Public access blocks rejects public exposure paths. Terraform state can contain resource IDs and outputs. Backend storage should not allow accidental public reads. This control protects state even when policies drift. Server-side encryption protects stored state at rest. AES 256 uses S3 managed encryption keys. Terraform does not need a separate KMS key here. The backend remains low cost and simple. State locking prevents two writers from changing state together. The S3 backend now supports native Lockfiles. Use Lockfile replaces the older DynamoDB locking pattern. One active writer reduces state corruption risks. On a submarine, two watchstanders cannot control one valve independently. One person has control, and the rest coordinate through procedure. Terraform state needs the same discipline. Two applies against one state file can damage the record. Backend configuration is not normal managed infrastructure. Terraform reads backend settings before loading resources. Bucket resources cannot configure their own backend dynamically. The backend move happens after the bucket exists.